It's my great pleasure to introduce Dr. Charles Weiner. Dr. Weiner is coming from us from the Johns Hopkins College of Medicine, where he's the International Vice President of Academic Affairs, the Professor of Medicine and Physiology, and the Osler Internal Medicine Training Program Director Emeritus at the Johns Hopkins School of Medicine. He's also professor in the Alexander Gras Humanities Institute at the Johns Hopkins University Krieger School of Arts and Sciences. The remainder of his bio is in here, but the reason that Dr. Weiner came to my attention and he's at our retreat today is that he had given a very inspirational talk at the National Science Foundation when they had put together a similar kind of retreat talking about curricular reform. And I had watched all of the lectures during that retreat, and his stood out to me as being inspirational, and really he's going to talk about why, the time for paradigm change, because I think as medical care professionals, we're very much in the rut, or at least I'll speak for myself, see one, do one, teach one. I was taught this way. There's nothing wrong with how I turned out. It's kind of what my kids, say things to me like that drives me nuts. But I think that change is very, very difficult. And I think understanding why change may be necessary, where those change processes come from, and looking at the history of change in medical education will really help us to try to take on this concept and provide a framework for the rest of the day. So thank you so much, Dr. Weiner.
That's it. Holy crap. Now I'm confused. Let's try that. End of slideshow. Okay, well, first of all, thank you very much for that great introduction. It's great to be here. It's truly an honor. And this is one of my favorite topics. I love talking about curriculum, medical education, and curriculum change, and I look forward to a discussion. I will say in advance that my goal here is to be probably 80% entertaining and 20% illustrative. So I'm setting the bar pretty low, but I'm happy to talk about whatever you guys want to talk about within that context. So we have to start with disclosures. I am neither a philosopher nor a historian. I am a clinician, I am an educator, and one of the reasons I went into medicine was when, as an undergrad, I read Lives of a Cell by Lewis Thomas, and it inspired me. It was a great book, I remember it. But I found this quotation from Lewis Thomas that I ardently disagree with. He said, one reason why medical history is not much taught in medical schools is that so much of it is an embarrassment. I fully disagree with that. There are many embarrassing aspects of it, but I think teaching history is one of the ways that we inspire people, and it teaches us to recognize how smart our predecessors were and how flawed they were and how we can constantly do better. And that's one of the things I'm going to talk about today. So my objective is that we are in the midst of the next paradigm shift in medicine, and therefore medicine education and training. And I show up here 2 advertisements from paradigms that thankfully we're no longer in, where doctors advocate smoking. But I think it illustrates that how far we've come and how we have to constantly be questioning ourselves to change and get better and question our basic assumptions. Now, I will also say that I am not going to talk about pedagogy very much, if at all. I'm happy to talk about pedagogy. I'm talking mostly about the framework about how we structure our medical education, how we structure curriculum. So I'm happy to talk about pedagogy and methodology and process, but what I'm trying to do is go one step upstream from that. It's like, how do you decide what are the goals and objectives of your curriculum as you design a brand new curriculum, which is a process, I'll tell you, that we did at Hopkins for 5 years. You'll also notice that, yeah, that's okay. At Hopkins, everything has to start with William Osler, and it turns out he was a remarkably cool guy. And he did a lot of great things. But here's a quote. I'm going to show some quotations that show how prescient he was, actually. And this is 1895. And I wish we could write like this again. I mean, people don't write like this anymore. This is more than 140 characters, too, by the way. Like a living organism, truth grows, and its gradual evolution may be traced from the tiny germ to the mature product. Much of history is a record of the mishaps of truth that have struggled to the birth only to die or else wither in premature decay. Or the germ may be dormant for centuries, awaiting the fullness of time. And one of those germs, my posit, is that we are now in one of those points in time where one of those germs is germinating. So I have a daughter who majored in English, and her focus within English was in something called creative nonfiction. She came home and told me that, and I said, Maggie, You'll hear about Maggie later on. Maggie, that sounds like plagiarism to me. Something is, if it's nonfiction, it can't be creative. She said, that's actually not true. And we talked a lot about the difference between fact and truth. So, and William Faulkner quoted on that, facts and truth really don't have much to do with each other. But from my definition, and you guys are in Washington here too. I mean, this is not, this is, holy crap. I forgot. I just came to I'm in Washington, D.C. You guys know this better than anybody in the world. But for my definition today, let's call a fact that is something that actually exists. It's what you observe, and it's often dependent on technology. But the facts are what you observe, and they are inarguable. They should be inarguable. Truth is how you take those facts and you put it into something that you understand. Okay? That's my definition for today. And what I'm going to talk about is that truth evolves, that what is truth is no longer truth. What is a paradigm? Because I talk about paradigm shifts. A lot of people use the word paradigm. It's become one of the more overused words in the English lexicon. But how many people have actually heard of this book, The Structure of the Scientific Revolution? Okay, how many people have actually read this book? Okay, less than 5. That's about, it's not an easy book to read. It was written in 1962, and it changed a lot of the ways we think about the evolution and the development of science. And interesting, it was not written about medicine. It was mostly about chemistry and physics, but it applies very, very well to biology. So Thomas Kuhn in 1962 took the word paradigm, which is an outstandingly clear or typical example, an archetype, and he redefined it within the context of science to be a set of beliefs that are sufficiently unprecedented to attract an enduring group of adherents away from competing modes of scientific activity, but at the same time is sufficiently open-ended to leave unresolved questions for investigation. So it's the notion of what is true to you within your scientific discipline at that time. And the fact that he writes stuff like this sufficiently, etc., that's why only 5 people have actually read the book. Because the whole book is like that. Although I'm going to show you one book that even less people have read. So what Kuhn said, and this is why it really has endured, I think, endured the test of time, is that research under one paradigm is a strong stimulus to induce paradigm change. So what he calls normal science, that's the research that goes on within the boundaries of the current truth of the current paradigm as you know it. And what happens is you find novelties of facts or inconsistencies or things that don't fit that lead to novelties of theory and paradigm shifts. And what was the revolutionary thought or hypothesis of Kuhn at the time is that science does not advance in a linear fashion. It advances in linear fashion within the context of one paradigm, but then all of a sudden, as a result of the overwhelming burden of the novelties of fact, you get a paradigm shift or a seismic shift where you have a totally new understanding of science. And then you start accumulating more facts, and then you kind of have various paradigm shifts. Interesting that Kuhn says back then, and still true, a new paradigm must seem better than its competitors, but it need not explain everything. So no paradigm is going to be true forever, within science at least. They're going to be evolving, and then having these seismic shifts. So science advances by normal science. Why was this an innovative thought? Because he says that textbooks, literature, people like us tend to blur these paradigm shifts because we never want to say that we were totally wrong. We want to say that, oh, we always knew that was coming. So what happens is it always made science seem very linear, whereas in fact it was not linear. So what I'd like to do, and this is the entertaining part, is talk about the prior medical paradigms. The other point about medical paradigms I forgot to mention is that oftentimes paradigm shifts are instigated by technological innovations. Why? Because new technologies allow us to observe things that we were not able to observe before and take us to new places that we did not think we could be before. And so technological innovations tend to be the operational methodologies by which we induce paradigm shifts, and that'll be relevant to us right now. So let's briefly go through the former medical paradigms, and this is the entertaining part. So circa 500 BC, medical education and medical practice kind of revolved around the fact that deities controlled health and disease. Therefore, religious figures dispensed health, and therefore in order to appeal to the religious figures, you would develop shrines, you would make sacrifices, and the medical education paradigm was right here. So that if you had symptoms, it was because some god was mad at you, okay? And what would you do? You would appeal to that divinity, or you would use some magic to try to relieve your symptoms. And whether or not you got better or worse was totally dependent on what the gods thought of you and your sacrifices and your prayers and all that sort of stuff, okay? That's the medical paradigm, and that's how we train people. Therefore, what was the medical belief? So that's where Asclepius came. He was the son of Apollo. He was the god of medicine and healing. He started the healing cult. The healing cult revolved around Asclepius. And obviously everybody recognizes his staff. Interestingly, Asclepius' daughter was Hygeia, the goddess of cleanliness and hygiene, who became the school of public health deity, as it were. Interestingly, Asclepius was actually killed by Zeus because he was alleged, because Hades was upset because he was allegedly stealing people from hell. He was raising the dead. Possibly he may have actually been getting some people better who were meant to die, and the gods got pissed off, okay? So that's why Zeus wound up killing Asclepius. But if you accept this as your medical paradigm of the time, what is the obvious thing? Well, here's the first tertiary referral center. This is the ruins of the sanctuary for Asclepius at Kos, Greece. This is where you would go to get your healing. You'd go to the central, the tertiary center, because that's where they would have the best shrines available. They'd do the best sacrifices. They would have the best appeals to the gods. All makes sense at that time. What happened? Well, the Greeks came along in 600 BC. And again, by the way, I've lived in Southeast Asia for many years. It's not part, it might be in my bio, I don't know. But this is a very Western-centric view. I'm not getting much into China, but China would be very interesting to talk about here too. But let's talk about the birth of the scientific method, which was based on rigorous observation and deductive reasoning, started by Pythagoras, Socrates, Plato. And what was their observation? They observed that liquid was the source of life, okay? They saw the spring, that the rains and the clouds would bring plants to life in the spring. If you drained a tree of its sap, the tree would die. If you drain a human of its sap or its blood, the human would die. Therefore, what is the logical conclusion at the time is that liquid is the source of life. And out of that came the Hippocratic corpus. Hippocrates was the great, I don't know how many of you here are active researchers, but Hippocrates was the first great lab research leader. Why? Because he had over 70 medical works, none of which he wrote, all of which were done by his grad students, but all were attributed to him. So he gets complete credit for everything that was written, although it's not clear how much of the work he really did. But he induced the first paradigm shift in medicine away from the deities, and his paradigm, or this paradigm, is going to last about 1,500 years, okay? So what did Hippocrates come up with? And it was actually Aristotle and all these guys, these Greek philosophers at the time, who were coming up with this. They came up with the humoral theory, which many of us have heard of, which is based on the four elements: water, air, fire, and earth, and the four dispositions that go along with that: the melancholic, the phlegmatic, the sanguine, and the choleric. And what Hippocrates actually wrote, this is from the corpus, is that the humoral body contains blood, phlegm, yellow bile, and black bile. These are the things that make up its constitution and cause pains and health. Here we go. Health is primarily a state in which these constituent substances are both in correct portion to each other, in strength, quantity, and are well mixed. So again, drawing on this observation that all life springs from fluids, he's coming up with a way of how we can have a complicated system of four different fluids that determine health and disease by having good mixing and adequate strength. And so here's his diagnostic credo. To put it briefly, and again, this is all from the corpus. To put it briefly, the physician should treat disease by the principle of the opposition to the cause of the disease according to its form. This will bring the patient relief. But out of this comes cupping and purging and blooding, and it's to restore balance. Now, there's a lot of parallels with Chinese medicine at this point, although they have a 2x2 model, 1x1 model. It's okay. But look what he also observed. And again, remember, the only powers they had, only technology they had was their eyes and their brains. But he said a phlegmatic child is born of a phlegmatic parent, a bilious child of a bilious parent, etc. He described heredity in 600 BC, and he described it incredibly accurately. for those of us who have children who are either bilious or, I know I have one of my child who's phlegmatic. So he observed heredity, and he came up with an idea for heredity. They explain why. How do you explain widespread disease? Well, widespread disease is because I impart upon you some of my bad humors, you bring those in, and they just cause imbalance within you. So it's actually a very, very good observation, and I challenge you, as I go through this talk, thinking about what tools those people had at the time to observe or analyze, could you come up with a better idea? Because in my case, I can't in most cases. These guys were actually very, very smart, and they were guys at that time. They were very smart, and they were very disciplined. So Galen comes along about a few hundred years later. He's a Roman physician, and there, this is the birth of kind of the Judeo-Christian religions, and function was determined by God. He still was very much an advocate of the humoral system, but God was controlled. There was a lot of teleology at that time. And so what happens is that the precepts that Galen's going to come up with appeal to both the evolving Christian and soon-to-be Islamic traditions, and that's part of the reasons that they're going to stay for as many years as they stay. But Galen advanced knowledge of anatomy a lot. He was a remarkably observant guy, and he did a lot of great work. You were not able to do human dissections at that time. It was forbidden. So he dissected animals. But he described bone and muscle structure. Why did we have bones and muscles? He figured out that the kidneys produce the urine and not bladder. Remember, if you were just doing a basic observation, you would see urine in the bladder. Why would you not think it came from the bladder? He actually found the ureters and described that the kidneys produce urine. He did a lot of great work on neuroanatomy. He described 7 out of the 12 cranial nerves. He described the meninges and how they could become inflamed. He did contralateral. There was a lot of trauma back then, right? He described contralaterality, the brain, that injuries on one side of the brain would affect the other side of the body. He also figured out that if you injure a spinal cord, it causes paralysis. He also discerned the arteries and the veins. Now, he did not have any systemic. He could not observe the capillaries. Why? No microscopy. He did not get to the pulmonary circulation. Why? Probably because of animal dissections and just some boundaries of thinking. But he did find arteries and veins, and therefore he came up with this physiology. And this is Galenic physiology, and this is going to last for about another 1,000 years. The brain is the seat of the rational facilities, the source of the nerves, sensation, and motor. He knew that if you have an injured brain, you did not have cognition. He figured that out. He also knew about sensation and motor. Pretty darn good, right? The heart is the seat of the passions. That's why we have Cupid and we have a lot of those things. No, seriously, it all comes back from this. The heart is the source of the arteries. And all the arteries go out to the periphery, and they send life-giving arterial blood and the vital spirit. That's what keeps us alive, keeps us active, to the body. Now, interestingly, he also figured out digestion, the portal circulation, and he hypothesized that the liver was the source of all the veins, and the veins delivered nutrition to the body. So there were two systems working in parallel. The arteries gave vital spirits, and the veins gave nutrition. Now again, I challenge you to, absent knowing about capillaries, it's pretty tough to overcome or refute this physiology. It's a pretty good thing, and this was the basis of their medicine, how they practiced medicine, using the humors. That's why a lot of the stuff having to do with the veins and the arteries were different, et cetera, et cetera. It makes a lot of sense. This progressed throughout the so-called Dark Ages and the Renaissance, so that most of the practice of medicine was bloodletting, purging, and kind of balancing humors. Drugs were known about. They were thought to work by alchemy, that they could shift one humor into another. So they could make your black bile, if you had too much of one bile, if you gave the right drug, it worked. If it worked because it shifted your fluids one into another. They knew about cautery, they knew about surgery, and they explained the Black Death, again, by evil spirits that would kind of alter your internal humors. Many people believe that during this time there was little scientific progress because the churches controlled science, and they liked this paradigm perfectly well. And just like Galileo and other people, there was resistance to more scientific inquiry at that time prior to the Renaissance. So what happened next? So around 1550 to 1650, and I'm giving these two people credit arbitrarily. You can argue about this. This is just my interpretation. I'm going to say that along came Vesalius and Harvey to overthrow the Galenic paradigm and bring on what I'm calling at this point the anatomy physiology paradigm. Who was Vesalius? He actually just all he wanted to do is he wanted to become royalty's physician. That was his goal. But he was a very smart guy. He started human dissection, or he popularized human dissection, and he started doing it by spending a lot of time in the cemeteries in Paris. But then he became a professor of anatomy at Padua, and you're going to see in a couple seconds who else was at Padua. It was a remarkably robust place. But he became a full professor at the age of 23. Not bad. Not bad. I don't know if we should aspire to that. His great work, which I hope your university has a copy of, but if they don't, we all should have an opportunity to see, is called the Fabrica, was published in 1543, and I'll show you a couple observations from that in a second. But that is the definitive work of anatomy, where essentially everything that's in the Fabrica is as good as all the contemporary anatomy books. And in fact, it's more beautiful. But he got almost everything right about human anatomy, and he got away from the animal model, thinking about human anatomy as a discipline, and he's the father of human anatomy. Interestingly, he became the physician to the Emperor Charles V, and he never published another work again after that. That was it. His successor at Padua was Fallopius, who your dean is an OBGYN I saw, so he obviously worships Fallopius. But yeah. So these are some of the drawings from the Fabrica, which is just an amazingly beautiful work. It is said that some of the drawings were actually drawn by the studio of Titian, and that's one of the reasons why so much of this is just beautiful artwork. But absent the artwork and the posings, it's just remarkable, and I hope you all have a chance to see an original copy at some point. But the anatomy is dead-on accurate. It's very, very good. But to me, it's William Harvey, who comes along a number of years later, who really just tossed out the Galenic physiology. He also went to Padua in the early 1600s, and look who else was there. Fabricius, Galileo, Descartes, Bacon, Boyle. That was really a center of European Renaissance thought at the time. It was a great place. He wrote his definitive work, De Motu Cordis, in 1628, and it's called Concerning the Motion of the Heart. And this is going to Harvey described the circulation, which is going to toss out Galenic physiology. And it turns out that, interestingly, the great Arab physician Ibn al-Nafis, 400 years before, had questioned some of Galen's ideas for how things got out to the pore. Galen had postulated some pores in the central thorax, et cetera, et cetera. But didn't really come to it. But there's well, he's not famous, he should be famous, amazing Spanish guy called Servetus, who got it exactly right. He proposed a circulation and a pulmonary circulation about 50 years before Harvey. The trouble with Servetus is he was a brilliant guy, and actually this book, if you ever get a chance, this is a great book. Out of the Flames, the remarkable story of a fearless scholar, a fatal heresy, and one of the rarest books in the world. Turns out Servetus wrote a book that described circulation and the pulmonary circulation, but he did it in a way that actually he also questioned the Holy Trinity. He did a lot of things in the evolving kind of Reformation. He was in Switzerland, which was the capital of Calvinist thoughts, and the Calvinists were not the most tolerant people in the world. So it turns out that he pissed off both the Catholic Church and the Protestant Church, so that to some point they actually burned him at the stake in Switzerland, along with every known copy of his book. So nobody got to read the book, and that's why it's one of the rarest books in the world, but he actually got it right. And this story about this it's a wonderful book about an absolutely brilliant guy. But it also teaches you to just be careful who you piss off. But remember, I'll tell you, Harvey knew about that. So this is the only figure in De Motu Cordis. This is how Harvey, by looking at the veins in the arm, discerned that the blood was not flowing from the liver out to the extremities via the veins, but yet the veins brought blood back to the central circulation. And it's this single figure where he just did some really good observational studies that he's going to toss out Galenic physiology. But look what he wrote. My conclusion, these are Harvey's words, my conclusion is so novel and unheard of character that I not only fear injury to myself from the envy of a few, he knows about Servetus and what happened to him, but I tremble lest I have mankind at large for my enemies. I mean, this is high-stakes science, right? So he began, and then he goes on to write, he describes the circulation, that that blood flows in a circular fashion, okay? So this tosses out galenic physiology, because remember, Galen had two parallel circulations. He calculated, actually in Democritus, he calculates that the liver would have to produce 3 times the body weight in blood per hour in order to have a circulation that he calculated. He got it right that the heart is a 4-chamber pump. He described systole and diastole. The valves ensured one-way flow. And then over the next couple years, more what I call within the Kuhnian thing, normal science comes out, where we figure out, Harvey figured there had to be a connection between artery and veins. He did not describe the capillaries. Malpighi did that about 40 years later, again, even before they could see it. And then Luer described blood changing from blue to red and going through the lungs, approaching oxygen, et cetera, et cetera. We didn't get microscopy till the mid part of the 1600s, late 1600s, and it was only then that we could actually see red blood cells, we could see capillaries and all kinds of stuff. This is all the normal science, I think, that kind of consolidated and led to that paradigm shift, which I'm calling, again, physiology anatomy. Interesting story about, if you ever want to do more history of medicine, the discovery of oxygen is a great story. Turns out nobody in North America or England knows about this guy Scheele, who was a Scandinavian who actually probably discovered oxygen at the same time as Priestley. It's a good story. But what are we missing? We have physiology, we have anatomy, we need microbes, right, in order to come up with the next paradigm. And I'm ascribing this to these 4 people: Jenner, who did smallpox vaccination; Semmelweis, the father of hand washing. Interesting story there. Virchow, the famous pathologist, actually hated the idea of hand washing and actually actively destroyed Semmelweis's career, such that he died in poverty and ignominy, largely as a result of the great Virchow. Pasteur, the vectors and all other and purification, etc., and Koch and the 4 postulates for infectivity. So what I consider is that microbes, physiology came together to define modern medicine, and that's going to be the paradigm that I think goes on from like late 1800s up until 2003. And here's just some more modern medicine. These are some things that got discovered. And this is what I'm calling normal science within the paradigm of modern medicine that came in the 20th century. Now, people could bicker with me about whether DNA, Watson-Crick, was paradigm shifting. I say it's not. Personally, it's my opinion. But remember, I'm neither a historian or a philosopher, so you can't, I can say whatever I want to say. But it turns out that if you go all the way back to the early 1900s, they knew that there was a molecular mechanism of heredity. Everybody knew that there was a molecular mechanism for heredity. What Watson and Crick is they defined what it was, but people had been looking for it for at least 30, 40, 50 years before they actually discovered DNA. So that's why I'm considering that normal science. Okay. You'll notice that I list all the Hopkins Nobel Prize winners, just because if I ever give this talk at Hopkins and I don't list them, I get in trouble. Okay. And actually, two of them are very good friends. But what about U.S. medical education? Well, to me, we would not have a U.S. medical education system that we have now were it not for these 2 great women, both of whom were in Baltimore. They grew up as neighbors to each other, and Mary Elizabeth Garrett became arguably the greatest female philanthropist of the Victorian age, of the late 1800s, early 1900s. Her father was a colleague of Johns Hopkins. They were early investors in B&O Railroad, et cetera, et cetera. She never married, and her father adored her, and she was a brilliant woman who her father recognized. So he included her in all her meetings, and she was a great biography about her. She never married for many reasons, but one of which was that she never wanted to let a man control her money. And she kept control of her money to the day she died. M. Carey Thomas was her neighbor. M. Carey Thomas, as best I can tell, was the first U.S. woman to get a PhD. Even though her father was on the board of trustees of the new Johns Hopkins University, they would not let her in to get a PhD, so she had to go to Germany to get her PhD. She came back to the United States, and she was the 2nd president of Bryn Mawr College, the Seven Sisters, and she's arguably the leading female educator in the United States, and she is one of the reasons why the Seven Sisters came to prominence. She was an amazingly bright woman. And what happened was, when Johns Hopkins died, he gave $7 million to start a university, Johns Hopkins University, and a hospital, Johns Hopkins Hospital. And they were meant to open a medical school at the hospital, but because of the stock market crash of the late 1880s, they did not have the money for that.
So they ran out of money. They needed to have money to start a medical school because they had actually already recruited Osler and Halstead and Welch and all those great physicians, but they didn't have the money to open a medical school. So they went and had a nationwide thing. They couldn't find any donors. Mary Elizabeth Garrett said, I've got money, but I've got some ideas, most of which she came from her conversation with M. Carey Thomas about education, rigorizing education. She said, I will give you the money. Johns Hopkins Board of Trustees said no at least twice, probably 3 times. We don't want your money because you're a woman. And they said, we'll find it elsewhere. They went back and forth and back and forth. She held to her guns. She was not going to give the money unless they agreed to her stipulations, which I'll show you in the next slide. They finally went back to her after about 5-8 years, and they said, well, we said we needed $500,000, but turns out we need $750,000 to do this. And because they think that she's going to, at that point, she's going to say no. And she said, you got a deal. Here's my stipulations. Johns Hopkins Medical School, which opened in 1893, thanks to Mary Elizabeth Garrett, $750,000, will be coeducational. Now, I heard that you guys were coeducational before that, so I applaud that. But Johns Hopkins started as coeducational. You required a college degree for admission. Prior to that, anybody could go to medical school, and you saw from the original Howard data, you could attend some lectures. It was not a rigorous structured curriculum. They created a 4-year 2+2 curriculum in 1893. And look what they did. They reduced lectures. That sounds familiar. They emphasized seminars. They had laboratory teaching. They instituted patient contact. They integrated basic sciences with clinical mentoring. They fostered a relationship between a hospital and medical school. And they engaged instructors in research and made preclinical professors full-time teachers. 1893, folks, okay? We can't think of ourselves as novel or innovative if they were doing it in 1893, right? So what happened? Well, Abraham Flexner, who was from Louisville, Kentucky, who was an educator, he's not a physician, was commissioned by the Carnegie Foundation under the commission of the U.S. government to review every medical school in the country. How many people have actually read the Flexner report? Seriously, honestly. How many people have looked at it? Okay, but very few people read it. It's the second most boring thing I'm going to talk about today. But it's incredibly comprehensive, right? It's amazing. And he recommends shutting down a lot of medical schools. But what he did is he said Hopkins was a model medical school. And I'm not tooting horns because he did say it. He said this should be the model, the 4-year curriculum, having a college degree before you start medical school, et cetera, et cetera. That should be the standard by which all U.S. medical schools should be held. The U.S. government endorsed the report, and that's why we have 4-year medical schools. That's why you have to have a college degree before you start medical school in the United States. And that's why you don't have to do that every place else in the world where you can enter medical school at a secondary school, which I believe is a terrible model, and I'm on a crusade internationally to get rid of. Because I think our model is far better for a lot of reasons. What happened within the 20 years after the Flexner report, over half of the medical schools in the United States went out of business because they just could not maintain quality. And those that stayed in business reformed to advocate this model. William Osler, again, he started clinical clerkships, he created residency training, and he was a strong advocate for bedside teaching. So in my mind, the medical curriculum between 1893 and 2008, I lived in Malaysia for 4 years, from 2010 to 2014. Formula One racing is huge. They love it there. Nobody in this country even knows what it is. But I call this the machine model of medical education. And essentially, this is the way many of us were educated. Year 1 normal, year 2 abnormal, year 3 and 4 clinical clerkships. And if this looks familiar, whatever. I will tell you that two of my crusades at Hopkins between 2003 and 2008 were to totally eliminate the word normal from, and you'll see why in a second, get rid of the word normal out of entire medical curriculum, out of pedagogy, out of the way we teach medical students. Get rid of normal, therefore get rid of abnormal, because the answer is going to be, I don't know what that is. And the second thing that I fought hard for 5 years to get rid of was totally get rid of the word preclinical. It's a terrible word. It's a terrible word to use in education. There should be no such thing in medical education as preclinical and clinical. You can call things non-clinical and clinical, I'll give you that, but the whole notion of preclinical is outdated, even it should be outdated. So I think there was tension to the paradigm and a lot of schools went through curriculum reform between 1993, 2008, actually even before that, including our school. There were a lot of things going on that caused all of us pre-2009 to adjust our medical school curriculums. A lot of new biomedical knowledge. But I will tell you that when I was in charge of the curriculum reform at Hopkins, I reviewed some of the minutes of notes of a curriculum reform that took place in Johns Hopkins Hospital in 1920-something, late 20s, early 30s, and the chair of pathology at that time, who's Hammond, his name was Hammond, wrote in his notes, say, "We have no way as a faculty to cope with the elephantiasis of knowledge that is invading our medical education. We're overwhelmed with how much to teach the students. We don't know what can we do to change our medical curriculum given this overwhelming burden of knowledge that we suddenly have." And what was happening in the late 20s? They were just thinking about antibiotics, right? So all of the problems that we bitch about, we complain about, pardon my language, all the problems that we whine about as faculty, they go back 150 years. Nothing is new. But there was a lot of things that were clearly happening to all of us. Changing hospital patient demographics, far more outpatient, less inpatient. Society wants us to teach appropriately about disparities, outcome safety, multidisciplinary topics that we had to incorporate into our curriculum, safety, aging, pain, nutrition, ethics. Every single interest group had an interest that they imposed upon our curriculum. We had to be better communicators. We should be teaching about professionalism and health policy, not only teaching about it, but modeling it, et cetera, et cetera. And don't ever forget the LCME. They're always making us crazy. There was also internal tension to the paradigm. De-departmentalization of curricula was very, very common in that era. Course integration by organ system, which we did also at Johns Hopkins. New pedagogy, thinking about pedagogy. How do we become lecture dependent, like things that they couldn't accomplish in 1893. The growing importance of clinical educators and community-based care. So all of these things were going on within our curriculum, but my hypothesis, my belief, is that they didn't change the paradigm. And here's a cartoon I always try to use, and I'm not going to say who's speaking. Look, I can't promise I'll change, but I can promise I'll pretend to change. We were doing a lot of stuff with medical curriculum, but I don't think any of it was really paradigm changing. I don't know if I have time for a case, but a quick case. This is actually my daughter. This is Maggie, the same daughter. She came home from college, and I will also tell you that her mother, Maggie's mother, my wife, is an infectious disease specialist, okay? She had left flank pain, dysuria, and anorexia. She was a collegiate rower, and she was still a rower. We told her for 2 days it was a pulled muscle. We were wrong. Her mother, we finally took her to the urgent care center, and she had a blood pressure 100/70, her heart rate was 105, her temperature was 39, she's alert and mild distress, and she grew E. coli out of blood and urine 12 hours admission. That's not the whole story. Actually, her mom, my wife, had given her some Bactrim. Turns out in Baltimore, Bactrim-resistant E. coli is everywhere, and the E. coli that she grew out was resistant to Bactrim. Okay? That's probably why she got so sick. So 12 hours later, I love the Washington Nationals, not really. This is the Washington Nationals scenario. After fluids and antibiotics, her blood pressure and heart rate are normal, and everything gets better over the next 14 days, which, thank God, is what happened to my daughter Maggie. Now, I'm an ICU physician, and this is the New York Yankees scenario. Despite fluid and antibiotics, her blood pressure falls, requiring vasopressors, and then she develops multi-organ failure, and it's this kind of stuff in the ICU that I see. And this is actually a patient that had E. coli sepsis, right? And my daughter had E. coli. Why the difference? This is from Up to Date, which I know none of us believe in, but I pulled it out because it was, you know. This is Dancing with the Stars, folks. You can't discern why somebody who has E. coli, and this is what we taught. This is what we taught at Hopkins. You can't tell me why, oh, well, whether patient does good or bad is good cytokines or bad cytokines, right? That's the machine model. That's saying, well, if your car's broken, we'll fix the carburetor. Sometimes it's not the carburetor, it's the fuel injection. I don't know much about cars, whatever, okay? But this is just Dancing with the Stars. This is meaningless information in my mind. What we now know is that the reason why Maggie did well was, fortunately, she had a good bacteria and she had a good host. And it was the interaction between the bacteria, because she didn't get antibiotics within 3 hours, trust me that, okay? That might have helped also. What we now know is that it's the relationship between the bacteria and the host that determine which pathway you take. And none of this is important to know, other than these are the relevant things to understand about the patient. And that's going to be the genesis of the new curriculum that I advocate for and is part of the next paradigm shift. This is Oswald Temkin, who's a brilliant, he's a physician and historian at Hopkins. He's the chair of the Department of History and Medicine at Hopkins for a number of years. And he said this in 1963, there's no science in the individual. And modern at that time, but still true until recently, modern medicine suffers from a fundamental contradiction. Its practice deals with the individual while the theory grasps universals only. And we were teaching universals, not teaching individuals. Now, astute clinicians know that, and wait till I show you the quotation from William Osler at the end. Never mind. What was the technological advance? Technological advance was the elucidation of the reference genome in 2003. That's what got us a new form of observation. It's just as important as Harvey observing the circulation. We have a new way of looking at people that's going to change our understanding of health and disease. Science, this was 2000, that was 2003, this is 2007, that the breakthrough of the year is human genetic variation. Uh-oh, how do I go backwards? And I show you this book because we'll talk about this in a second, but this is a really interesting book to read. I will tell you that it now costs less than $1,000 to sequence a genome. But not only do we learn about the technological breakthrough, I call the technological breakthrough genes, but we're learning so much more about public health. We're learning more about how to provide health to the population and how to be socially accountable, et cetera. A lot of stuff is going on, and I think these things are paradigm shifters in my mind. This is the most uninterpretable book of all the ones I've mentioned so far today. This is by a great Hopkins pediatrician and geneticist, Barton Childs, what he wrote in 2003. And this is not a genetics book. This is a logic of disease. But here, his entire book is sentences like this. But this is a really important point. Diseases are caused by the independent action of neither genes or experiences, but by the influence of each other on the protein products that are the unit steps of the homeostasis of specific individuals in whom they coincide for reasons traceable to phylogeny and culture. I know. I'm one of 3 people that read that book. It took me an entire summer. But here's what Barton was trying to say. So Barton Childs, I was the director of the human pathophysiology course in the old new curriculum at Johns Hopkins. I did that between about 91 and 2003. Barton, who was at that point about 90, comes in my office, and we still gave handouts to the Hopkins students. We still do, I think. And he said, "Can I look at your handouts for human pathophysiology?" And he sat at my office for like a week and a half and put little note marks where everything we were teaching the Hopkins students wrong, okay? And there were a lot of them, trust me, there are a lot of them. And here's one of them. This is a slide from the bone and mineral. So we already had an integrated organ-based curriculum at this point. We had that since 1987. This is from our bone and mineral density section where we talk about osteoporosis. And every person knows this slide. Bone mineral density is on the y-axis as a function of age. Black women are in the black dots. White women are in the white dots. It's in the United States. And what we would teach our students is that as women age, they lose bone mineral density. And that's what we teach. And I said that to Barton, and Barton said, "Charlie, you're teaching the Hopkins students the wrong thing. You're teaching them the curve, and the curve does not really exist. What you should be teaching them is the error bars, because the error bars are important. What you should be teaching the Johns Hopkins students is that as a function of age, some women have remarkably rapid bone mineral density loss such they are great risk for all kinds of diseases, whereas some women have almost no bone mineral density loss as a function of age. And what you as physicians have to do is figure out whether the woman sitting in your clinic is the rapid loser or the slow loser. Because if you treat the average, you're not treating anybody." That's what we should be teaching. That's how we should be organizing our curriculum. And when he explained that to me, the light went off for me. I really understood it. That was the best explanation I ever heard. And if it's obvious to you guys, applause. So out of that conversation came the new Gene Society paradigm for the Johns Hopkins curriculum, which I spent 5 years working on, and we can talk about if you'd like to. And it starts with patient phenotype, that there's always a patient that centers around the phenotype. And that everybody, all of us in the room, live somewhere on this continuum between risk and latency and critical illness. Right now, thank goodness, most of us are down here. But there's stuff going on inside of us that we don't know about, right? But we're feeling pretty good today. Where we are in general is a function of what, this is back to Barton Child's uninterpretable quotation. Where we are is a function of what's going on inside of us, which is a function of our genomics, our cell biology, our organ physiology, and modulated by what's going on the outside. Our behavior, our community, our family, and our environment. And I cannot underemphasize the effect of behavior enough. Behavior is vital, obviously, okay? And what we should be teaching our medical students is to think about medicine within this paradigm, not a car that either breaks down or runs well. And if you accept this, then I don't know what normal and abnormal is anymore. I know what typical is, and I know what atypical is, but something is not normal and abnormal. What's normal urine output? I don't know. It depends on how much fluid I've taken in. If I've taken a lot, it's a lot. If I've not taken anything and I'm running a marathon, it's 0, right? So we have to frame everything in the context of the individual patient. And it's not all about genetics, because it turns out these things are remarkably important too, and we have to teach about all of it, okay? So this is the curriculum. We spent 5 years, and we did deploy it pretty much all at once in 2009. It looks like this, and I'm not going to talk anything about I'm not going to go through this, but unless you want to, because it doesn't look that different in a lot of respects from other curricula, but the framework around which we teach the precepts of health and disease is different. That's why I said I'm not talking about pedagogy. I want to talk about framework and structure. But it also highlights why we no longer have the word preclinical anymore, because right here we do clinical foundations. We start with disparities, and we do clinical foundations in day 1. If you're doing clinical foundations, you can't call that a preclinical curriculum. The preclinical curriculum is what happens in college. Okay? Let's let the undergrads use that word, not us. We also had horizontal strands that we viewed the curriculum as a tapestry that had vertical courses and horizontal strands that transcended no single course, that extended throughout the year, and we had a variety of topics that we chose where the students should get more and more sophisticated knowledge as they became more and more sophisticated. So just teaching about pain in the first year is not the same about teaching in pain in the 3rd year or the 4th year. You need to complicate the comprehension as the student becomes more sophisticated. And you need to do that longitudinally with deliberate repetition, not non-deliberate repetition. That was one of the big things we talked about, was deliberate repetition as opposed to non-deliberate repetition. Because it turns out we had a lot of non-deliberate repetition in our old curriculum. We actually taught abdominal pain 5 times from different perspectives. And depending on what section you are, the most common cause of abdominal pain was either appendicitis, an ulcer, or a pregnancy, a non-tubal pregnancy or something like that. Ectopic, thank you. So what is the individuality model of medical training? How do we define disease? And again, we do this from the moment the students arrive. So this is their framework upon which they learn everything. It's an alteration in your individual homeostasis. Why do humans get disease? Intrinsic makeup and external factors. Both are equally important. Why does this person have this disease? Importantly, why do people not get disease? If 100 people smoke, turns out only 20 of them get COPD. Now the other 70 might get atherosclerotic disease. If I breathe flu on all of you, only about 30% of you get the flu. Why do people not get disease? That's just as important, and we never used to teach that. Why does this person have disease now and not yesterday? Now, if they got hit by a car, it's obvious. But if they come to your clinic today and they have a fungating breast mass and they didn't come yesterday, what happened that brought them today? That gets into behavior. That gets into a whole lot of non-biologic things that are really important for our people to understand. Why did they not come yesterday or the day before? Why are they seeing you today? What happened? What can we do to restore this person to their unique steady state? And how can we utilize our knowledge of this individual and these individuals to prevent disease and maintain health? Now, I will tell you that this is not a play against public health, because it turns out, and I'll show you this, it turns out that vaccinating everybody sometimes is the right answer, because you can't figure out who's not going to get the disease. So it's not against anything. It's saying that individuals, a group of individuals become families, communities, populations. It's all important to think about those also. When we came out with this, there was a lot of things about that we were way too early, and Johns Hopkins faculty saying, no way, it's not broken, don't fix it, et cetera, et cetera. We couldn't do this. And we kept showing this quotation from Robert Watson, the president of IBM. I think there's a world market for maybe 5 computers, and I think some of you have 5 computers in your pocket right now, okay? iPad, portable computer, at least 1 or 2 cell phones, et cetera, et cetera. So again, just shows how wrong we can be. And he was a smart guy, Robert Watson, okay? So the individual paradigm is coming about. It doesn't matter, it's whether you're a psychiatrist, asthma, osteoporosis once again. Obviously, the oncologists are way ahead of us on this. They're the ones that we should be imitating, because they are way ahead of the game with individualizing understanding of both disease and management. Here's from the New England Journal. Genes are important, CDX2, predicting colon cancer. We can now use really, really advanced tools to predict colon cancer and heart disease. But it's no less important that we understand how to control disease at the population levels. That's why we call the curriculum Genes to Society. Neither is one more important than the other. They're both important. Here's, this is actually a family member's where they actually genotyped her tumor. This is a breast cancer tumor, where they actually did a genotype of her tumor. That's individualized medicine. And they prescribed therapy based on the mutations in her tumor, not just some average 60-year-old woman's tumor. They're going down to that level right now. It's amazing. Does anybody know who this is? That's James Watson. Does anybody know what this is? I don't know what's doing that. That's exactly what it is. He was the first human to have his genome. You know how much it cost? Yeah, so it's depending on how you want to parse out the cost. It was somewhere between $10 and $50 million. It now costs $700. Okay? Now, it is still true that we have no idea what to do with this information. We're getting ideas, but we do not yet have the knowledge to what to do with it. We can get it technologically. But remember, the technological advance often precedes the knowledge that derives from the technological advance. This is some of our patients who are getting 23andMe or Navigenics, and we tell them not to, but they do it anyway, and they come in and they say, well, what the hell does that mean? And we say, you shouldn't have done it. But at the same time, we should be able to explain to our patients what they're trying to tell you, et cetera, et cetera. And this gets back to medical education. We need to be teaching our medical students and our residents and young doctors why they should be saying don't do this, what it means when they will be able to do it, because this is going to come. It's going to happen. We've got to start teaching them now. This is from Stanford, their new taxonomy of disease. I don't know. There's a lot of arrows here. I don't know what the hell that means. But I will say that I think whether you call this personalized medicine, individualized medicine, or precision medicine, I don't care. I think at Hopkins, we don't like personalized medicine because that reeks of boutique medicine, and we don't like that. I think individualized medicine is good, precision medicine maybe even better, don't care. But it's all the same stuff. Here's the next one that's going to hit us, okay? Just when we started to understand with our own genome, then our own epigenome, which is just coming out and is very important. Next thing we're going to know is our metagenome, what's going on in our bowel. It's all going to be, and what lives in your bowel, turns out it's going to impact some people's health. And we have to be teaching about this. This has nothing to do with the machine model. This is individualized medicine. Here's an interesting study from 2010 where I think people are going to start going. And it's not ready for prime time, but I think this is a provocative way to think about it. What these guys did is at Stanford, is they found one individual, and they took a remarkably comprehensive family history. They took a remarkably comprehensive behavioral history. They took a remarkably comprehensive daily life activity. And they figured out where this person had any risk at all. They then correlated at that time, this is 2007-8, using SNP technology, which is old technology already. They tried to correlate with what were the genetic risk factors known at that time for the various diseases. And they created what's called, they call an individualized gene-environment interaction map for this person at that time. And I think this is the way we should be thinking about this stuff. So on the outside are this person's behaviors and his risks based on his family history. The bigger the type, the greater the risk. So you can see he smoked, he had a stressful job, he didn't exercise much, he had a bad diet, et cetera, et cetera. On the inside, modulated by the genetic risk factors known at the time, were his risks of disease that were a combination of his behaviors and his genetic risks. And this is the kind of thing. So you can see this guy's at high risk of obesity, osteoarthritis, coronary artery disease, type 2 diabetes, more so than depression and some of these other diseases. But what this is trying to do is contextualize for students, and we've introduced this to our students, that you have to be thinking about the outside circle and the inside circle, and the next person sitting next to you who have very similar behaviors could have very different risks of diseases. That's what the individualized medicine paradigm is all about. It doesn't mean we don't teach physiology. It doesn't mean we don't teach that sort of stuff. We don't call it normal and abnormal. We talk about typical and variation. We talk about human variability, but we still teach all the same stuff, public health, physiology, et cetera. What are the implications of the Gene Society curriculum for the individual and for the student? You have to appreciate the complexity of disease and systems biology. These are all networks. If you haven't read a book called Linked by Barabasi, to understand what link theory is, it's a very, very simple, easy book. It's a great analysis, and it really, really applies to the human physiologic condition. It means we have to think about how we define mechanisms of disease and new definitions of disease. Many of the autoimmune diseases, turns out, are anti-cancer diseases. Scleroderma is being a great example. That turns out many forms of people who have scleroderma are fighting incipient cancers, and the driver for their autoimmunity is a cancer. And in the growth of immune therapies for cancer, that's not surprising. We have to rethink how we define risk and prevention, not only for individuals, but also for publics. Both are important. I really think we have to rethink what we call evidence-based medicine. A lot of the trials out there did not adequately phenotype patients. There's a lot of studies out there that were negative studies because they clumped a lot of patients who didn't belong to be clumped. There's a lot of studies out there that are said to have a clinically insignificant result with a statistically significant result. The Jupiter trials won. We have to rethink better who are the individuals in the trials as we think about what is evidence. Because I don't think everybody who has certain diseases needs all the same therapy. We should be thinking about individualization as much as we can. It makes you have to take a history and talk to your patient. Great thing to do, okay? Turns out the family history is really important, and their exposures, their environment, where they live, what they do, turns out to be a crucial aspect to whether or not they're healthy or not. And that should be taught to our students from day one. Pharma industry both loves and hates this paradigm. They hate it because not everybody in the world needs Wellbutrin. But on the other hand, it's an opportunity for them to design new targeted therapies which have changed the course of disease. Herceptin is one that has totally changed our understanding of breast cancer, for example. But not every woman needs it. So we have to think about how we prescribe drugs. So in summary, I believe we are in the early phases of paradigm shift in medicine relating to individuality and variability. I think we need to be trained in the context of this paradigm in order to advance clinical care and research. We have to learn how to phenotype our patients better. We have to understand complexity, systems biology, and network theory. We need to know our individual patients, and we need to know the communities in which they live and their behaviors. Our medical curricula should take into account all of this stuff and should start with this framework and then build on after that, however you'd like. And whatever pedagogies you like to use, however you design the specifics, but this should be the framework about which we think about our future physicians, because it's going to be taking care of us. Truth is dynamic and must be advanced and modified through research. So whatever was true when we went to medical school may not be true anymore. So let's think about new truths. President Obama bought into this in the latter years of his presidency, and he always, look at this quotation. This is great. Again, more than 140 characters. Doctors have always recognized that every patient is unique, and doctors have always tried to tailor their treatments as best they can to individuals. But medical schools have not tailored their curriculum to that. That's my posit. You can match a blood, et cetera, et cetera. What if figuring out the right dose of medicine was as simple as taking our temperature? So he's advocating for precision medicine. But look what William Osler said in 1903. Variability is the law of life. No two faces are the same, no two bodies are alike, and no two individuals react alike and behave alike under the abnormal conditions which we know as disease. Osler knew that in 100 and whatever number, 14 years ago. he did not have the tools to discern the differences back then and to come up with therapeutic ideas that were better to change behaviors, etc. But he knew about this stuff way back then. We now are at the first era where we actually can individualize therapy, and we can individualize that, and we can teach our students in that precept. So with that, I will say thank you and say sometimes it helps turn a question around. Why not you? Thank you.
My mind has been blown, that's all I can say. I'm sure there are plenty of questions, so if you'd like to, if anyone has a question, if you'd like to find a mic, and please ask that.
Got questions or just leading? Doesn't matter.
Certainly, I want to make a comment. Thank you, thank you, thank you.
Thank her. Thanks, Fluffy.
On time, on point, and on purpose. Howard is unique in having in a historically black university a National Human Genome Center. From that center, we came out of partnership with NIH at the time, 2003. 2001, we were founded, but when the genome was sequenced. Howard got its beginning because there was a recognition that there has been a major omission in the resources that we have gathered for this human genome project. And that omission was Africa. And Howard got its foundation and a major purpose when it came into being, bringing Africa into the haplotype project, which was to establish variation in population. Obviously, you know that. I say that because somehow I feel like we've been preaching the message that you deliver so eloquently. And I thank you for the 80% entertainment. It was very, very easy to receive, but the 20% information. And it's so on point, and it's such a rich time for this university, simply because of how you ended. Variation, the key to understanding biology. Biology, the key to practice of medicine in the way that at least I heard it. So thank you.
Sure.
Thank you, thank you.
No, I will say that, going back years, so, for example, I lived in Southeast Asia for 4 years, and it's quite clear that the Southeast Asian phenotype, which is not as heterogeneous as the American phenotype or genotype, the Southeast Asian phenotype, which is much less heterogeneous, they do not respond to, they have a huge problem there with obesity and diabetes. Huge problem. But it turns out that they get abnormal A1Cs at much lower BMIs than North Americans and Northern Europeans. It turns out that they respond differently, and even their beta cells in the lab respond differently to insulin. Therefore, all of the guidelines that are coming out of North America and Europe may or may not even apply to Southeast Asia, or they have to be reinterpreted to those people. Treatment of hypertension in the room. Some people know, some people respond to diuretics, some people don't, some people respond. This is why I say we have to rethink evidence-based medicine. What is the evidence too? It's good stuff.
Thank you so much for your, I guess, very fantastic presentation. One information which also Dr. Dunstan just mentioned about the data. As you know, the big data is there about the genome, integration of the omics, and which is transcriptomes, metabolomes, mutation, and as you look at the big data, the representation of minority is very, very small. And we really have to encourage for getting those data out and the risk factor for that. As you mentioned some of the genes here, we know some of the genes specifically for the family, the variant is different, and therefore having those data for the patient or risk factor is very important. And you mentioned about also the history, and it's very interesting that you have mentioned several people who have been contributed in the medicine. And since we are living in a diverse region here in Washington, D.C., and we have a so-called program at NPR, they call it Trump effect. And this Trump effect is just showing that how we live together in a harmony, but also there is some which is coming at the minority and also minorities like other regions in the world. And so I want to mention that the Indian and Chinese medical philosophers have also incorporated in the medicine. And also Persian, Iranian also, one of them was Razi, which discovered alcohol. And you mentioned coke, which is important for bacteria, and actually the alcohol was part of it. And the other part was the Ibn Sina, which was also is part of the history of medicine, which has 5 books and anti-inflammatory also information in these 5 books, which has been also contributed in the Muslim/Persian medicine. And I think another things which you also mentioned, which was very important, is teaching and information, which, as you know, the difference between the student and the teacher now is only analytical values, because they do have all type of information on their laptop or on the cell phone, and how you can do analyze between the teacher information and the student information analytical. And this massive information, as you mentioned, is very important to have the analytical value for the bedside.
Yes, so thank you very much. And yeah, one of these days I'm going to put together a whole nother talk on the Islamic empire and how they were some of the great universities and things. So I've read a moderate amount about that. I think you're going to hear more about technology from Dr. Spickard, because he turns out he's a millennial with gray hair. So he's going to tell you that, because I am the wrong person to ask about anything I'm doing with technology. I do think that, you know, as one of the things we've all learned is that we have to adjust our pedagogies to our constituents, and I think that's going to be part of what Anderson, I'm looking forward to hearing. When 2 of you now have mentioned the issue of minorities, and I have great respect for Howard, and I know your mission, and I love it, et cetera. And I think it's important that you stay true. I love that you stay true to your mission. And it makes no more sense. So it turns out, I assume you have Indian descent. Is that right? So it turns out as far as I know, I've not done 23andMe yet, but I have no I have no Indian blood in me, no South Asian blood in me. It makes no more sense for a medical curriculum to think that she and I are the same, then it makes no sense. But yet that's the way I was educated. I had to come up with that conclusion myself during residency, or maybe even just last year, I don't know. Whereas I think, relating to the specific topics you're teaching, the day the students walk into your medical school, they should understand that we are different, and we're different, you're different. Now, in some ways we're similar, in some ways we're different, and that variability is the precept for basically how we stay healthy or not. That's all I'm saying. So I agree fully with what you're doing. I do think you guys have a great platform upon which to do it, too.
I think it is needless to say that it was real inspirational, so thank you for inviting me.
I can't hardly hear you. I'm sorry.
I think it is needless to say it was truly inspirational speak. But I had a question how to translate what you said. I stopped reading a suspense book when I started physiology and biochemistry. I thought medicine was a lot of fun, but what I find here is that students are more concerned with USMLE rather than the fun part of medicine. So what I'm struggling, how could we encourage students that USMLE is important, but first aid is not the answer, or first aid is not a foundation to be a good physician down the road? While they're concerned with having good scores and getting a good residency, how could you encourage them that probably it doesn't matter what we teach, it matters what do they think it is important?
Well, but let's not forget that that NBME is a peer organization, okay? I mean, NBME is us. So what we need to do is if the USMLE, and we can talk about USMLE, that's another topic, but I think they can, will, and should move towards whatever the prevailing medical, I mean, they're responsive, they're not proactive, they don't make knowledge, they reflect knowledge. So it's up to us to make sure the tests reflect what we want our students to accomplish. Now, that's another topic though, I think.
Very nice presentation. Just a couple of comments. I think one of the things you're saying is that also social context is so important in how you interpret the undergraduate medical education. Came in really early this morning, made the internal medicine residence round at 6:30 so that I could be here. We had a new woman with a pulmonary embolism, and they had ordered factor V Leiden, African-American woman who weighs 300 pounds. My comment to the residents was, you've ordered $3,000 worth of genetic tests, and factor V Leiden is only found in 5% of the Caucasian population, maybe 40% of those with PEs, but it's almost universally not found amongst African Americans. And that's where we've taken paradigm, factor V Leiden, risk factor for thrombosis, and now into practice, and we're practicing it outside of the social context. And it's so important, and I think we're going to have to address all of these issues because my point to them was exactly, this patient is not what you've been taught in physiology about factor V Leiden, which is described in Leiden. Its highest prevalence is in Sweden. That's not reflective of every population in the world.
I 1,000% agree with. And now, if the resident had said to me, I ordered that test, even though I know if the student, I know this, and this, and I got my brother-in-law to run it for free, I wouldn't disagree with that. But if they started with that, I would have done it. But what you're saying is, and I think this is endemic, if not pandemic, that it's the spinal reflex practice of medicine rather than the cognitive practice of medicine.
So I'd go even a step further. If you go to the Leiden Thrombophilia Clinic, they don't test factor V Leiden because it makes no difference in your clinical management. So again, you're spending $3,000 on genetic tests that aren't going to influence your clinical practice, and you're testing it in probably a low yield population. So we've taken paradigm in the medical education, and it's translated into the hospital, and it's wasting resources, time, and effort, and not benefiting the patient.
So all I would ask is that you don't use the word paradigm there, because I think what they're taking is bad practice and systematizing it. But yes, I agree with everything you're saying. Yes, ma'am.
Yeah, I actually wanted to follow up on that comment and ask the question of, as you're doing this paradigm shift of sort of individualizing medical education on the undergraduate level, how does the practice look in the actual wards where the students are going to be interacting, the residency programs and the practice? Is it aligned? So in other words, you're beginning the theory, but is that individualized? Is it something they see in practice? And is it something that the physicians who are trained in a different model are actually applying those? So how does that continuum look?
So that's a great point. So it's easier, so I can speak to Hopkins individually because I still do that. And getting it through to the clinical rotations was the framework. Still a lot of faculty development, and conceptual, but thank God for the students, they asked those questions. They would start asking questions, and we all learned from the students asking questions. The harder thing that we've had is integrating that into graduate medical education. And I don't know, and we have one program, I've talked to some pediatricians about how do we orient pediatrics residents to this framework also, because I think the next step I would love to see would be for it to be actively perpetuated into graduate medical education. Although now, remember, the pipeline effect, hopefully, if it works, we're going to have people who think in that way as they go out and they teach the students, et cetera, et cetera. But in terms of structured graduate medical education, I'm not aware of anybody really pushing it as we are in medical education.
That was a wonderful talk. I have a comment and maybe a vision question for you. In my education to the first couple of years of medical curriculum, I always taught the student about the standard, looking at the standard error, the variation, rather than the actual numbers. And I think the future is indeed for individualistic medicine. However, the question is, and I would like your vision or your idea about it, since research is based on power analysis and not on individualized observation, how would you translate that? How would you see the research supporting individualistic medicine, since both are contradictory on that end?
Well, I don't think they're contradictory. I think they are complementary, but they can be muddled easily. I agree with you. And I think this gets to the power of, it's all about table 1 in every paper, right? Who are the patients that are in the study that you are studying, and how does that apply to the patient that you're seeing in front of you right there? So that's why we always say table 1's the most important table, or the exclusions, who did they exclude from the trial? So I think, and this gets to my general thought about better phenotyping of our patients. Better, and when I say that, I don't mean based on genetic analysis, I mean understanding about who that person is sitting in front of you, the social determinants, etc. So we have to understand better who they are, because the literature is important, and the literature is trying to come to grips with this too, so that they don't inordinately clump patients either. But at the same time, so researchers are coming up to the grips with individuality and variability very, very quickly. Cancer doctors are a great example. I was just at a talk yesterday, right around the corner from here, about asthma, where now there's neutrophilic asthma and eosinophilic asthma, and we shouldn't be clumping all asthmatics the same because they respond differently to medications. So the researchers are thinking this. They're ahead of us, the clinicians typically. But the clinicians know that they have an individual treatment, and what we need to be doing is teaching our students and our young trainees, our residents, to think about the person sitting in front of them in the context of what they read from that evidence, where it applies and misapplies. That's how I would do it.
Good morning. Thank you also. This is a great presentation. You talked about preclinical and trying to take the word preclinical out of the curriculum, and now we're talking about individualized medicine. I think one of the things that people do see a lot of times is you have the basic science component and the clinical component. With this structure, do you see integrating, kind of getting rid of that 2-and-2 system, and maybe even having a more integrative where literally you start on the wards, based on where you are in your curriculum?
I totally. So I'm not sure what basic science even is anymore. I mean, you can call things discovery science. There's all translational science, etc. So I think and I think words matter. I do think words matter. This is Washington again. This is controversial. Words matter. So I think telling the students that there's something of a preclinical or a basic science at the exclusion of non-basic. So I think you have to come up with labels that transmit what you like. Because even my idea non-clinical, because everything's clinical in some respects. So I think how you describe your curriculum is important, but I do think that in terms of the experience of the student, they should be thinking about human health within the capacity of what they can think about it from the moment they arrive at your medical school. Yes. And whether that's just learning basic communication skills that we all need and that a lot of undergraduates don't have, that may or may not be contextualized towards medicine, but in day 1, yes, learning about disparities, learning about population health, learning about behavior. The undergrads nowadays have a tremendous capacity to absorb all that. So let's just start it on day 1 and not wait any longer.
Are your students still, do they just still wait for 2 years to go on the wards?
No, of course not. No, and I can talk more about it. So they actually start a half a day, in the current curriculum, they start half a day in a community-based clinic in January of their first year. So they get the basic preparation, communication skills, physical diagnostic skills up front very quickly, and then they do a half day a week clinic that runs for a little over a year, starting January of their first year.
Hi, I enjoyed your talk a lot.
80% entertainment.
Yeah, I do like entertainment, and I like history as well, so that's okay. At any rate, you seem to have just a little disdain for the analysis, say, coming from companies such as 23andMe, which will provide people or individuals with ancestry data and a probability of maybe some susceptibility to disease.
So,
I'm going to add.
Go, you finish your question, okay.
And here's the other part. So we got that group doing it, right? So I may be a little wrong about the 23andMe. But then you had Theranos, they're not in business. They've been kicked, called into question about the validity of the data and the reliability of them being able to say an individual had a certain type of
Right.
genetic makeup or resulting in disease. So basically my question is, one, these types of companies may have issues with reliability. Do you foresee a point in time when such type of genetic analyses can be standardized, something that we can all trust? Because when you now look at the cost of sequencing a genome or for an individual is down to like $700. And I'm thinking like just going to the hospital in an ambulance can cost you $2,000. This is not a big deal for trying to get better and more personalized or individualized treatment. So again, I understand you said the best thing is what? Oral history. But again, tell me
So
what you foresee in terms of this.
So let me ask the second question first. So I have no doubt whatsoever, within the next decade or less, we will have the ability to translate, no, let me rephrase that. We already have the ability to take genetic data and translate it into important differences in therapy and risk already. BRCA1, BRCA2, breast cancer. We already have that. I think that it is I think it's a certainty that in the next 10 years, many, if not most, of the complex diseases, diabetes, chronic obstructive lung disease, asthma, heart failure, hypertension, are going to have similar abilities to discern the differences between two people who have the same ejection fraction or have the same blood pressure, such that you will be able to individualize therapy. I'm 100% certain of that.
There's so many linkages that are going to be required for.
And latency. We're going to understand all those things better than we do now in a huge way. Now, and then what's going to happen is we're going to say, well, we still can't explain a lot of people, and it's going to turn out that epigenetics are not explained by that, or the metabiome is going to explain some of that. And then we're going to do more science, and we're going to come up with a new paradigm, okay? And we're going to keep advancing knowledge. But I'm 100% sure that the genetic data that Jim Watson has in his hands is going to be some portion of that is going to be utilizable already, next year, and every year more. 23andMe, I'm tempted to do it because I think the whole evolutionary stuff in your ancestry, that's kind of cool. I mean, I just think that's kind of cool. But when someone says in the Navigenics, when it said you have a 23% risk of inflammatory bowel disease versus a 27% risk, what in God's name does that mean?
Right.
That doesn't tell me anything. So that's why I have disdain for that portion of it.
Okay.
Now, do I think that we're soon going to be able to identify people who are at risk for certain things? We're going to redefine risk, absolutely. And that's coming faster than we think.
Okay, one final thing, and this is just an opinion. In terms of evolutionary time, how long is, in your opinion, how long has cancer been a part of living organisms?
Cancer?
Yes.
Goes back to Hippocrates.
Okay.
Of course.
All right.
Sid Mukherjee's, what's it called? The Emperor of All Maladies. Great book. Talks about that a lot.
Hello, Mr. Billings. This is my expert here. Thank you.
Thank you.
I just wanted to take a minute to thank Dr. Weiner again for that excellent plenary session.